Alright, so today we get a slight break from power rules. Instead, what we're going to do is learn how to translate. Again, these next 2 days are based off of translation, which means it's a different type of skill. But today, again, we're going to translate fractional powers into a new form. The first thing we must learn how to do is translate the basic fractional exponent. There are two terms, though, that must be learned to make sense of directions. And what I noticed as I was looking at your work is that the biggest issue a lot of you are going to have is when you read the directions, you're not going to understand exactly what it's saying, and then you're going to allow that to confuse you. So you might want to write down these two definitions or these two terms so you understand exactly what it's looking for. A rational exponent. Keep in mind that a rational number is a decimal fraction, anything like that. You know that the exponent is the small number. So when you see rational exponent, it pretty much means an exponent that's a fraction. Alright, so again, rational exponent is a fractional exponent. The word radical is the symbol used for roots. So the radical is this symbol right here that you've seen on your square root. It's this key or the button that is the part that comes up whenever you hit second x squared. That brings up a radical symbol. Okay, so again, rational exponent means a fractional exponent, or radical is that weird symbol that you use for square roots. Today's instructions are going to ask you to rewrite without rational exponents. Another set of instructions might want us to write the expression in radical form. When it says rewrite without rational exponents, it's meaning I don't want any. It says without, so I don't want fractions in my exponent. Alright. If it says write in radical form, pretty much it's again saying that it does not want a fractional exponent. These are both asking for the same thing. They're pretty much saying to translate the fractional exponent into a radical. So just keep that in mind as we work whenever you read those directions, because as we keep going forward, those directions are going to change, and you want to understand what it's asking you for. Some real quick examples on what you do. It's going to say again, rewrite without rational exponents and simplify. Notice here is a rational exponent because we have a fraction in the exponent, and so all you do is you take the base of the power and you put it right outside of the root, inside of the v portion of the root. Not in front of the root, but again inside the v, and then you put whatever this is, and it would be x to the first, but we don't write a first power, so it's just the fourth root of x. Alright, so again, all you do is you take this base, or sorry, the denominator, put it right outside inside the v portion of the root, and then put everything else inside. X to the 1/7. Again, what we're looking at here is that's your denominator, so 7th root of x to the first is what that would be. But again, because we don't write the 1, it's just the 7th root of x. And as you get used to it, you don't even write the 1 because you understand that that's just the 7th root of x as it is. X to the 1/2. Again, here is where you would start. But here's the point. You do not write 2's. Square roots, whenever you're talking about it, think about it. Square roots actually have an invisible 2, and so you don't write the 2 in there, you just write square root of x. Again, so the key thing you want to know in your notes, and you might want to write this down, is we do not write the 2. The 2 is the invisible number. Every other number will show up, but again, in our work today and in our work for this unit, actually in your work for the rest of math, you just do not write the 2. Alright? All the above exponents had a 1 in the numerator. But let's look at how we place the numerator if it's not a 1. So real fast, just looking at this, e to the 3/5. Again, the 5, the bottom number, goes outside into the v. And all you do, like we did with the 1, is we put the 3 on the inside. That is all. So again, 5th root of e to the 3rd is what that turns into. Here, you turn this into the 3rd root of m to the 7th. And that's all you have to do. Again, bottom number goes here, top number goes on the inside. A to the 4/9. 9 goes out, 4 goes in. That is our answer. Okay. So far that doesn't look so bad. It shouldn't look so bad because it's really not. But the hardest part of the lesson, there's two hard parts we have to discuss before we move on to our work. The hardest part of the lesson is learning when to apply the translation. The following questions cause the most problems for students whenever I looked at their quizzes, or whenever I look at their quizzes, because of the fact that we have to learn again when to apply the translation. And the directions are going to ask us to write it in radical form, which means we want one of these symbols. Alright. Notice you have 25x to the 1/2 with the 1/2 outside of parentheses. This is where you have to apply your rules. This 1/2 outside of parentheses means that it drops to both parts. So you end up with 25 to the 1/2 x to the 1/2. The first thing you must do is simplify what can be simplified. Well, 25 to the 1/2 I can type into here as 25 caret and then 1/2. And notice I get the nice number of 5. And so I want to simplify that to be 5x to the 1/2. Going back to our directions though, it says write it in radical form, which means that we don't want the fractional exponent. We want this to be written inside of a root. Well, here's the thing. The 1/2 is only attached to the x. It is not attached to the 5. It's just attached to the x. So this 5 is not affected, but this part becomes the square root of x. And remember, we do not write the 2 because it's a square root. Again, that's one of the things that should be in your notes right now, that we do not write the 2. But again, the 5 comes down, but this portion is the part that turns into your radical and goes there. Do not put the square root of 5x squared or 5x, because that's what I see a lot of people do. But again, that 1/2 has nothing to do with that. Alright, the only time that 5 would be in there is if you had this. And notice that the 1/2 goes to everything, and you can't do the 5 to the 1/2 doesn't turn to anything at all. Notice how you have a decimal, so that means that you can't simplify it, and that would turn into the square root of 5x. But again, you just got to make sure you learn that if this 1/2 is only attached to x, then x is the only thing that goes inside. Over here, 25x to the 1/2. Again, is this 1/2 attached to 25? No, it's not, so therefore the 25 stays the same. The x to the 1/2 is as far as we can go, but again, they want it in radical form, so that means that we don't want this fractional exponent, which means this one, the 25 stays 25, and this x, this portion here, goes into the root, or the radical as we call it, but it's also called a root sometimes. So again, you might want to make sure you keep those in mind when you get to your worksheet, because that is, again, one of the tougher parts of our day. The other difficult part, which isn't really that tough, is just making sure you read the directions, but the other part is making sure our final answers are in the proper form. You'll see something that says simplify the expression using the properties of exponents, which is what we've already been using, and then write the expression in radical form. Well, here's the thing. The first thing we know is that this is going to make us do something that we've learned over the last couple weeks, but then you get caught up so much in solving it or getting to that answer that you forget about the second part of the direction. So here we go. We have x. Neither one of these is floating outside of a parentheses, which means that this is the one where we add 7/8 plus 1/4. And again, the good news is we can do this here. And turn that into a fraction, which is 9/8. The next thing that has to happen though, again, once you do that part, most of us stop and say, okay, I did a great job, I'm done with that. But notice it says write the expression in radical form, which means that we don't want the fractional exponent. We want the root, which means we now have to take this answer and put our denominator inside the v and our other number as an exponent to the inside base. That is the issue. Again, I don't think that there's a major issue with us getting to x to the 9/8. I am just afraid that you won't turn that into the form that they want you to do. Alright. And again, same thing on B. You'll see the directions will say simplify the expression using properties of exponents, write the expression without rational exponents. It's giving us two sets of directions. The first thing we have to do is follow our rule. This 6 is floating outside of a parentheses, so therefore we should distribute it. So we end up with f to the 3/4 times 6, whereas the other one was adding. This one is multiplying, again applying those rules that we've been learning. And so we do 3/4 times 6, which gives us 9/2. But again, because of this second set of directions, without rational exponents, which means we don't want, it says without, which means we don't want fractional exponents, means that this now has to turn into the square root. Remember, we don't write the 2 of f to the 9th. Alright? So what we need you to do is use the rest of the hour to practice translating rational exponents to radical form, and also use that time to review and practice those power properties that are going to be expected to know for the test in a few weeks. I don't remember exactly when the test is, but I think it might be, hold on, I can look here. Your test is on the 30th, or sorry, the 20th of October, so it's the very last day of the quarter, which means that you want to make sure that you have all that understood. So pretty much you've got 2 more weeks to learn these rules. So as long as you're willing to keep learning, asking questions, and reviewing and reviewing and reviewing, you should be at least decent enough by the time that test pops up. Other than that, like I said, let's get to work. Remember, it's a short day, and good luck.